Inequalities. I know you've seen these before. Those are those little arrowy things. Some have a line and some don't. Some face left, some face right. So inequalities mean something like less than if I don't have a line but I'm pointing to the left, or less than or equal to if I'm pointing to the left and have the little line. If they face to the right, then we're talking about greater than, or with the line greater than or equal to. So it's just showing relative position to one another. If we're thinking about the number line, less than means I'm going to be to the left of something. If I'm greater than, I will be to the right of something. We are going to be working on solving linear inequalities. And in this case, we are going to use all the same techniques that we have used to solve regular linear equations. There's one exception though, and that is when we divide or multiply, mostly divide, by a negative number, we will flip that inequality symbol. Okay, we reverse it. That's the only thing we have to remember. Everything else is just like solving equations. So let's take a look at a couple. So 3x minus 5 less than 6 minus 2x. Normally we get x's to one side, numbers to the other. So we're going to do that here. I'm going to add the 2x to both sides, which means I'll move the 5 to the other side. And I have 5x less than 11. Divide by 5. I'm not dividing by anything that's negative, so I keep everything the same all the way through. It's all less than all the way through. So my inequality answer. Now, notation and vocabulary is important. So this is inequality. Right here, x less than the 11/5. So that little symbol, that's the inequality symbol, that's inequality notation. I might also be asked to graph this. So on a number line, I'd find my 11/5, which is going to be just a little bit more than 2, right? 11 divided by 5, just a little more than 2. And I want less than, so I'm going to shade to the left. Now you might be accustomed to using an open circle here to show that you get close to 11/5, but not equal to it. With college algebra, we've switched notation a little bit and we start using interval notation. And rather than using open circles to show we approach but don't include that point, we use parentheses. So that's where you see the parenthesis here. That leads me to the answer, which then, okay, so for the interval answer, it's where do I start, where do I end? Is pointing to negative infinity. So I start my interval with negative infinity and I end it at 11/5. I have a parenthesis around 11/5 because I'm not including that endpoint, and I always have a parenthesis around the infinity because, well, I'll never quite get there. There's always one more place to go, right? So you can never really include it. So the old notation, open circles to show that I don't include the endpoint. Now I'm going to use parentheses. And it goes whichever direction you're headed, right? Old notation, filled in circle to show you want to include the endpoint. Our new notation, we're going to use these square brackets. All right, so let's look at one more example of a basic inequality. I have 13 minus 7x greater than or equal to greater than or equal to 10x minus 4. If you are kind of used to graphing or moving the x's to the left, that's fine. You don't have to, but that does make sense. We're going to subtract the 10x, and then we're at the same time going to have to get rid of that 13 and move that to the other side. So now I'm ending up with a negative 17x is greater than or equal to negative 17. So when I solve, now I actually have to divide by a negative. And our rule said if you're dividing by a negative, that's when you have to flip that symbol. So in my next line, my answer, I actually have x is less than or equal to the 1. Okay? Deciding whether you flip or not has nothing to do with your answer. It's only how did you get that answer. All right, so x is less than or equal to 1. So again, on my number line graph answer, I would find 1. That's my boundary. This time I use the bracket because I want to show that it gets right up to and includes that endpoint, but it's less than, so I still shade to the left. The interval part, from negative infinity, because that's where it's pointing to, up to the 1. Always parentheses on infinities, whether it's positive or negative, and the bracket on the 1, just like on the graph, because I want to show that it is included. Now, some of you may have taken a slightly different approach to this problem, and instead of moving the x's to the left-hand side, you moved them to the right-hand side. So you might have added the 7x and then added the 4. That's perfectly fine. But when you finish your problem, you're going to end up with an inequality that looks like this. 1 is greater than or equal to x. Again, that's an accurate statement, but it's not as helpful for us when we are graphing. When we're graphing, we want to have our statement beginning with x. We want to know what's related to x or how things are related to x. So if I say 1 is greater than or equal to x, I'm really saying that x is less than or equal to the 1, okay? And so when I see it that way, that helps me to graph it and know that less than means I'm going to shade to the left. And once I get it accurately graphed on the number line, I can get my interval. So just something to watch out for. If you have questions, let me know.